Hi all, good morning, good evening. Welcome to the day 2 of our exclusive training, Generative AI in Software Testing, where we are going to learn how to leverage generative AI in the area of functional testing, automation testing, as well as performance testing, right? So we had the demo session in which we went through the course content as well as the introductory topics. And yesterday we discussed more details about artificial intelligence, the different branches of it, right? Then what are the different types of language models, large language model, small language model. So all those things we discussed. So we'll continue from yesterday, everyone. Okay. So before I start for the day, I would like to ask if anyone has any queries from the previous session, all of you. If anyone has any queries from the previous session. Okay, so I'll take it as a no. So we'll get started. So let me start sharing my screen. Please do not hesitate to ask questions. Whatever questions you have, you can ask everyone. Okay. Our objective should be to learn as much as possible. I hope my screen is visible to all of you. So yesterday, guys, we understood that the different type of language models are there, like large language model, small language model, right? Now, and I told, right, they are trained on the data sets, and then whatever input we give to the AI model, they will provide the output to us. Yes or no? Now, how does the artificial intelligence models, the AI models, how do they understand us? Yes or no? How do they understand us? That is very, very important, guys, right? To understand. So, when we are giving, okay, whenever we are giving an input, let's say we are giving the input in the form of text. We will discuss that, guys. What is that input I am talking about and all. So normally we are going to provide the input, like as you all are aware of the LLMs, the AI models, right? So we normally converse. Like the other day I was asking the AI model, who is the current captain of the Indian Test cricket team? Yes or no? So that is an input, or that is a question which I'm asking to the AI model to get some answer. I gave that input in the form of a text. Yes or no? I gave that input in the form of a text. So how does it understand us? How does it understand us? That is very, very important, guys. Whenever we are providing any text, okay, whenever we are providing text, that text is broken down into tiny building blocks. Whatever input we are providing, whatever text we are providing, that is broken down into tiny building blocks. So that building block, okay, that the smallest block, the smallest unit is known as token, everyone. Whenever you are providing any text, it will be broken down. Let's say you give a sentence, guys, okay. It has like 5 to 7 words. That will be broken down into tiny blocks. Each of the block will be called as a token. Now, what is a token? It is a single distinct unit. Okay, it is a single distinct unit. Now, many people think that each word will be converted as a token. Many people think that each word will be converted as a token. It is not the case, guys. Your whole word can be a token. Part of a word can be a token, or even punctuation marks like full stop, comma, question mark, exclamation mark, right? those punctuation marks can also be tokens. Are you getting me, guys? Whenever we are giving any input, that will be broken down into tiny building blocks, and those building blocks are known as tokens. The token can be a single distinct unit. It can be a whole word, it can be part of a word, or even a punctuation also. Now the AI models will interpret this token. They are not going to interpret your entire sentence altogether. They are not going to interpret your entire task, entire instruction, entire question altogether. They are going to, first of all, your instruction or your task or your question will be broken down into tiny blocks, and the AI models are going to interpret each block one by one, and then they are going to process them, and then based on that, so they will be detecting the pattern, they will be predicting the next word and all, and then they will generate, guys, and then they will generate basically. Understood? Now as an user, guys, as a user, when I am using AI, I am not aware of what all things are happening in the background. Like for example, this instruction or the text which I am providing, that being broken down into smaller units. As a user, can we see that, everyone? No, right? As a user, we are not able to see that. Yes or no? We are basically giving the instruction, we are giving the text, and that is broken down in the background. So the user is not able to see that. Okay, the user is not able to see that. So it is basically a background job for the LLMs. Okay. Now I'll show you one demo, guys, for the GPT models of OpenAI. Okay, how do they process? Now this process, guys, the breaking down of the instruction or the text into smaller blocks, distinct blocks, which are called as tokens. That process is known as tokenization. Okay, that process is known as tokenization. So how that tokenization work for GPT models, we'll see that, everyone. Okay. See all of you. Over here, we can see we'll be able to see the tokenizer for the OpenAI platform. We'll see that. Let it open. See all of you. The different models are there. Okay, GPT-4o, GPT-4o mini, and then the previous models. Now you see below, you can see that it is showing 0 tokens, 0 characters, right? Now let me give any text. I'll enter a text. Let's say I mention what are the benefits of generative AI. Okay, I ask what are the benefits of generative AI. There are total 7 words in it, right? 1, 2, 3, 4, 5, 6, 7 words and 1 punctuation mark, right, guys? So, but some would be thinking that there will be somewhat 7 tokens, 8 tokens. So the algorithm, or basically the tokenization process of OpenAI, you see, what is the number of tokens you see? Number of tokens
9.
is in. Are you getting me? when we are giving the text to the AI model, guys, all these things happen in the background. Are you getting me? So this text, whatever I gave, it was broken down into 9 blocks. 9 blocks. Okay. Now what are these blocks? And you see, it was able to find out what is the number of characters. And then you see there is a color coding given below. The 9 distinct blocks, how it basically broke it down. How it basically broke it down is given over here, everyone. So see, what is one block, and then space and R is another block. Then space and the is another block. Then space and benefits is another block. Then you see another block is space and off. Generative word, even though I told you, right, the whole word can be taken as a token, or part of a word can also be taken as a token. And what are we seeing here? We are seeing that generative got broken down into 2 blocks. Yes or no, everyone? You see, right? And then AI is another block. Question mark is another. So total, this text got broken down into 9 tokens, everyone. Is it clear? I don't know if it's clear.
Yeah, I think there's an issue with the connection. You're
Sorry,
not
are you
able
not
to
able to
hear.
see?
We're good.
Yeah,
You're not
but it's breaking.
Sorry, is my voice breaking for everyone?
No, it's okay.
No, you're good.
No, it seems okay for her side.
So I think you need to check your network probably, because I'm audible clearly for others. Thank you. So guys, this is our tokenization process. Okay, so this is happening in the background. Okay. That is why now what happens, the AI models, okay, the AI models or the vendors who are having these LLMs, AI models, they charge you on the basis of tokens. They charge you on the basis of tokens, guys. For example, your organization or your enterprise has procured any AI model. Now they will basically, when they procure it, they have a particular license. That license also includes that how much amount or how much tokens. It is normally in the range of millions or billions, basically the number of tokens which is allocated to your license. But once you converse with the AI models, your tokens, right, get deducted basically from your the organization's license. So whatever is the amount of tokens allocated, users, when they use that particular AI model, those tokens get deducted. So now tell me, guys, is it recommended that you, whenever you are giving one instruction or task, you write anything? That is not a good practice. You simply cannot, means the message which you can give in 1 sentence or 2 sentences, it is not recommended that you write 10 sentences for it. Are you getting me? So your token, because you are being charged on the basis of tokens, your instruction, your request, or your text is being broken down into tokens. That is why your text, your instruction needs to be precise, needs to be accurate, to the point. You cannot be very descriptive, or sometimes you cannot be very brief also, because if the problem is a bit complex, you need to explain it properly also, right? So you have to make a proper decision how to write the correct prompt. Then so how, in that case, how will you be able to write the correct prompt? That is why it is very necessary for us to learn how to write effective prompts, how to write correct prompts. That is where we have the prompt engineering. That is why it is very, very important that we learn how to write prompt engineering. Means how to write the prompts as part of prompt engineering. Clear, all of you? So this process of breaking down the data into tiny blocks is known as tokenization. So remember that, guys, whenever we are writing the prompts or we are writing the input text, we need to keep in mind that what should be the length of our input? What should be the ideal length of our input so that we are not consuming many tokens? We should write the prompts, we should write the text in such a way that the cost is optimized. Okay, cost is optimized.
I have one doubt here.
Yeah, tell me.
How to find the maximum input length, whether it is 6 characters or 7 characters or 5 characters? Do we know, or the system will only?
Means, are you saying like as part of the tokenization for each token, what is the maximum input length?
Yes, yes. Now, recently for generative, it divided into two tokens.
It broke down into 2 words. Yeah.
Yeah.
So that completely depends on the algorithm written by the particular vendor, right? Or the whoever has come up with the product. But when I am saying maximum input length means you should be aware basically that when you are giving the input text, right? Now, for example,
Okay.
I wrote what are the benefits of generative AI, right? I could have also mentioned list the benefits of generative AI. Yes or no? What are the benefits of generative AI? List the benefits of generative AI. In list the benefits of generative AI, I think I will have less tokens consumed.
Yes.
Right? So that is where I'm telling that whenever we are writing it now, this is a very simple task, right? Which I gave. It's just a very simple question. But when we are actually giving the problem statement to the AI models, we need to be a bit aware that we should not be writing very descriptive prompts. Also, the descriptive prompts will somewhat mislead the AI models also. Okay.
Okay.
Okay. So this is how, guys, the point which I was telling is like when we are giving the text, how the AI model is understanding us by the process of tokenization. Okay, it is understanding us by the process of tokenization. Clear, all of you? Now, moving on to the next one. How do these LLMs work? Okay, how do these LLMs work, everyone? When you are giving any text, when you are giving any instruction, when you are giving any request, when you are giving any task, the LLMs, what they do is they understand the pattern, guys. In your text, okay, they try to understand the pattern and what is the relationship between the words and phrases. Are you getting me? Whenever you are giving any text, the LLMs try to understand the pattern and the relationship between the words and the phrases, guys. Now, when they are understanding the pattern, when they are understanding the relationship based on the algorithm, right? So the algorithms have been written using the mathematical models of machine learning, deep learning, right? As we were discussing yesterday, NLP. So based on the mathematical calculation, so in the backend, okay, a lot of mathematical calculations will happen. Probability will come into picture, and based on that, the LLM will be able to predict the next word. Okay, it will be able to predict the next word. So it is basically processing, guys. Now, guys, let's say there is a discussion happening between a group of people. Okay. Let's say our forum. Now we are discussing, right? And let's say all of us are aware of a game known as cricket. Don't be surprised, guys. Everyone in the world is not aware of cricket. Very less, many very less countries also play the game, right? So everyone is not aware, and we have audience from different parts of the world also here, right? The trainees. So guys, whoever is not aware of cricket, like there is a game known as cricket. Okay, let's say we are discussing about a point that who is the greatest batsman in the cricketing history. And it has always been a debate, right? People from India say Sachin Tendulkar. Now the new generation says Virat Kohli, right? And then we have some other great batsmen like Brian Lara. And you can add to that list, guys. Okay. Now, guys, because this is not a very, to the point question, or it is not a question based on a fact, or it is not a point based on a fact, right? This will depend mostly on the data points or the data set. Now, let's say by going into the statistics of different batsmen, I say that means the outcome is that Sachin means if we go by the metrics, Sachin is the greatest batsman, let's say. Okay. But we all members, let's say we are 20 people or 25 people. Out of these 25 people, let's say we say that Babar Azam or MS Dhoni is the greatest batsman. Means out of 25 people, let's say 10 people, okay? 10 people, or let us not take names. Let's say 10 people say A is the greatest batsman. 5 say B. Another 5 say C. 2 say D. 3 say E. But actually, this, let's say, as per the stats, B is the greatest. But in our discussion, what has happened is 10 people say A. Right? Now, guys, by going into the probability, right? By going into the mathematical statistics, right? What would be the answer? 10 means basically A would be the answer or not? A would be the answer for greatest batsman. Similar is the case with the AI models, everyone. Similar is the case with AI models. If I train the AI model on this data set, because AI model will not be able to learn on its own. It doesn't have its own decision-making ability, independent decision-making ability. Whatever data set it is trained on, okay, whatever data has been fed into it, based on that only, it will be able to take decisions or give us the output. When I feed this data to the AI model, what it will do, when I ask that the greatest batsman in cricket is, it will answer me as A. Even though the stats would say as B, the answer I will get as A. Are all of you clear? Understanding me? So this is how the LLMs work, guys. Based on the data set, whatever they have been trained on, they will gather the information from that only, and then they will give us the output. That is why it is very, very important that we verify the output given by the LLMs. Okay? Clear, everyone? So it basically uses probability, guys. It basically uses the probability to generate the text. And which data it will use? It will use basically the data on which it was trained. So the data on which it was trained, it will use the method of probability on that data to generate the output. Clear? That is what I discussed, right? So it depends on the data, training data basically, for the LLMs to generate the output. Clear? So now the question is, yes, it is using the mathematical models, it is having that probability and all those things. But for that to work correctly, some mechanism has to be there, right? Some mechanism has to be there, some process has to be there. Yes or no? So how LLMs work and process our input, and the tokenization I told you, right? The tokenization process is there. How the LLMs get correct, right? How the LLMs get correct. Very, very important. So guys, there are different architectures. There are different architectures based on which the data is processed. The first one is serial processing. The first one is serial processing, and the next one is parallel processing, guys. Two types of architecture: serial processing, parallel processing. So when this concept of LLM or generative AI was initially, it was coming up, basically, the architecture was primarily based on serial processing. Now, let's say this is one text which I'm providing. Okay, what will happen is it will be broken down into tokens, right? Then the first token, let's say, then the next token, next token, next token, next token, and so on. Let's say this is my first token, second token, third token, fourth, fifth. Okay, it will first process the first token, then it will go to the second one. Okay, it will process serially, guys, one after the another token. Okay, first token, then second token, then third token, then fourth token. Now, when the text is long, basically we will have more number of tokens. What happens is, the objective is here to detect the pattern, right? But in serial processing, what is the demerit is, as it goes forward, okay, as it goes forward, it might lose the reference to the previous tokens. Are you getting me? In case of serial processing, because it was processing the tokens one after the another, when it was moving forward, it was very likely that it would forget. Okay, it would forget the reference to the previous tokens. So as a result, the pattern detection, okay, because if I'm reading and reading, but I'm forgetting the previous, items, then my detection of pattern could be challenging. I might not clearly detect the complete pattern properly. I cannot analyze the complete pattern properly. Okay, so that was the demerit of serial processing. So then what they do, they come up with parallel processing, everyone. Same parallel processing also, we have the tokens, right? Tokens. But when the tokens are being processed or when the tokens are being analyzed, here parallel processing will happen. So all the tokens will be processed in parallel. So what happens is, this token will have the, reference to other tokens. Similarly, this token will have the reference to other tokens. Okay. Similarly, this token will have the reference to, this will have the reference to other tokens. So as a result, the relationship between the different tokens is maintained. Okay, it doesn't forget. Okay, it doesn't forget the previous tokens. All this happens mathematically, guys. Okay, I'm trying to represent it pictorially. So in parallel processing, it is very unlikely that it will forget the reference to the previous tokens. So that is why the output, the processing, the analyzing, the interpreting, okay, is better in case of parallel processing. Clear, all of you? So serial processing and parallel processing. Because of the demerits in serial processing, we have the parallel processing. Now in this parallel processing, is there a query? If not, I'll request you to please unmute.
Yeah,
So,
actually, can you take an example and can you explain it clearly? We understood the theory, but serial and parallel.
yeah. So, yeah.
With an example, it would be better.
So as I was telling you, let's say I give some text, right? Now I showed you the tokenization process or not, right? Now token, there were 9 tokens in that. If I give a bigger task, bigger instruction, there will be more tokens. Now if there are 9 tokens only, it is very unlikely that it will forget the pattern because there are only 9 tokens. Means what will happen? First token will be processed. So it will process that text. What are the benefits of generative AI? So it will first understand the first token, that is what, then R, and then the one by one after the another token, it will try to analyze, process it, and then it will detect that pattern. Means what, as a user, I'm basically trying to ask. It understands that pattern, then it responds basically. It tries to generate the text as per the algorithm written in the AI model. But when the number of tokens are more, because that referencing, because when I'm going from first to second, yes, there is a connectivity like this, right? For example, there is a connectivity here. But when I go to the next one, the connectivity between third and first is not there, right? Then here, fourth is not having the connectivity with the first and the second, the reference basically. So when the number of tokens are more and more as I go forward, the LLM, the AI model, it is very likely that it would forget the previous tokens because the reference is not there. So the pattern detection could become erroneous. It could become faulty. But in case of parallel, all the tokens will have the reference to each other and they will be processed in parallel. So as a result, what will happen? The pattern detection will be better. Understood? Between the tokens. When it is analyzing that tokens, it is detecting that pattern. So the pattern detection will be better. As a result, the output will be more accurate. Okay. So that is basically our serial processing and parallel processing. Okay. So then moving on to the next. Okay. So guys, from the parallel processing, okay, from the parallel processing, we have now evolved into the transformer architecture. Now, most of the LLMs, as I told you yesterday, what was the full form of GPT? Who can tell me? GPT model. Yesterday I asked, right? GPT model. Means not asked, I showed this GPT model. Anyone? Generative pre-trained transformer model. Yes or no? Generative pre-trained transformer model, guys. So in the parallel processing, as the parallel processing is evolving, with the parallel processing getting evolved, the latest architecture being followed by the models, the LLMs, is the transformer architecture, everyone. Okay, transformer architecture. Now we will understand this transformer architecture. Guys, whenever you are reading any book, okay, or you are analyzing something, you are trying to solve a question, forget AI. I'm not talking about AI now. Whenever you are trying to understand any question, whenever you're reading any problem, whenever you are reading any article, does your brain, so when you read the complete thing, then you are able to understand it in a better way. For example, if you have read the question, half read the question, will you be able to understand the question completely? No, right? So to understand the question completely, you have to read the complete question. When you are reading the complete question, are you giving, all of you guys, okay, let's think upon it, okay? When you are reading the question, are you giving the equal amount of attention? Are you giving the equal amount of attention to each and every word you read? Think all of you and answer. Whenever you are reading any article, whenever you are reading any question, right, or you're trying to solve something, are you giving equal amount of attention to each and every word?
No.
All of you?
No.
Right? We do not give the equal amount of attention to each and every word. Correct, everyone? All of you agree or not?
Yes, yes.
We give attention to certain words in the problem, to certain words in the article. Or basically, the amount of attention is varied, right? Some words will get more attention, some will get less, some will get even more less, right? Now, how are you giving? Means how are you deciding, guys, whom to give the attention? How is your brain deciding? It has that inbuilt capability, right, to understand that which one is more important, right? So whatever is more important in that text or question or article, whatever you're reading, whatever seems more important to your brain, it will give more attention to that. Yes or no? Right. So the attention is basically decided on those parameters. Correct. Similarly, guys, the same kind of attention mechanism has been, it has been tried to replicate that kind of attention mechanism in the AI models. We're going to learn about that now. We're going to learn about that. Okay. So let us deep dive into this transformer architecture, everyone. This will be our input. Input means whatever text, okay, or question, means question in form of text only, right? For example, whatever input the user is going to provide. So guys, what did I tell you? What is the first step? What will happen? What is the first step? Guys, we have understood that. Forgot? Okay. The first step is tokenization. Yes or no? Right? The first step is
Yes.
tokenization. Whatever input we will give, that will be tokenized. Tokenized means tokens will be generated, right? Tokens will be generated. Now, guys, what will happen? Each token. So once we have the input, when the input is provided, it goes to, so we have one encoder and the decoder. Okay, we have one encoder and the decoder in the LLMs in this architecture. So when the input is provided, that is converted into tokens, then it goes through the process of embedding. So in embedding, what will happen, guys? each token will be allocated a position. Not position, numbers. They will be numbered basically. First, the tokens will be numbered. Okay. So the numbers will be embedded to the tokens, guys. So that is my embedding process. Clear, everyone? Next, once this, now because the parallel processing is happening, the parallel process, as I told you, right, this is part of parallel processing. So because the parallel processing is happening, the algorithms have been written, the models, the mathematical models have been implemented. Based on that, it will understand, okay, it will understand that which token is having more importance, which token is having less importance, and all those things. So once those numbers are given, they will be, let's say 1, 2, 3. So these token numbers are provided, and so on, guys. Okay. Now these numbers will be then will be allocated position. So the positional encoding will happen. In case of positional encoding, what will happen? Mathematical vector position. Okay, vector. Mathematical vector. We will not go into much details, guys. So the mathematical vector positions will be allocated to each of these tokens. Based on that vector positions, the mathematical models will analyze all the tokens because the processing is happening in parallel. Okay. Based on those vector position means it is kind of an index. Okay. So based on those vector positions, the the parallel processing will happen, and the mathematical model will analyze and interpret and find out which tokens need to be given more priority, which tokens need to be given less priority. So this is known as our self-attention mechanism. As I was telling you, when my brain is reading anything, right? So it will basically try to understand the entire set of tokens. It will try to understand the relationship between these tokens. So the tokens are what? Those are words or phrases or part of a word or paragraphs, right? So it gives that attention basically. So this is our self-attention mechanism. So which tokens need to be given more priority or more attention, which tokens need to be given less attention. That is basically done with the help of the self-attention mechanism. So whatever input you provide, these 3 steps will be followed in order to prioritize that, guys. In order to understand the relationship between the inputs, okay, in order to understand the relationship between the inputs and prioritize them, assign the position, and then find out which needs to be given more attention, which needs to be given less attention. That is my encoding part. The decoder, which I have represented here, it also has the same things. It also has the same things, but in reverse order, guys. In reverse order. The objective of the task of the decoder is now to process the output. The encoder processes the input. The decoder will process the output, but it will go in the reverse way, right? So based on this self-attention mechanism, now the model has understood which one needs to be given more priority, which one needs to be given less priority. Clear? So based on that, then the decoder will try to process the output, and it will generate the output by giving the attention to those high, those tokens which are having higher priority, higher attention, and based on that, it will basically generate the output. So self-attention mechanism will be followed in the decoder. So it generates, because now guys, when you try to understand any article and someone asks you to summarize it, will you take important points from that article, or you will take less important points from the article. You will take the important points from the article only when you are being asked to summarize, or when you write the answers, right? Your brain decides what should I write in such a way that my output is more accurate, is more correct. Same thing happens here, guys. Again, the self-attention mechanism will be employed to generate the output. Okay, what all things should be present in the output, that will be basically first of all decided, and based on their priority, based on their attention which needs to be given, they will be allocated positional vectors again. They will be allocated positional vectors, and based on the positional vectors, the tokens will be generated. So tokenization doesn't only happen during input processing. Your tokenization also happens during, means tokenization is there, means tokens are generated during the output also. Okay, and then the tokens will be numbered. The tokens will be numbered. So based on the numbering, guys, the sentence will be formed. The output which the model has to produce, the output which the model has to generate, right? It will be the sequence will be arranged in that particular manner. Understood? So self-attention mechanism, then positional decoding, and then embedding in case of the decoder. And once this process is done, okay, so the model has decided how to place the tokens, what will be the output, and then it generates the output in the form of the text, or whatever is the intended output given by the user. Okay, whatever is the intended output given by the user, the output will be generated in that particular process. So as a result, we are able to see the text or the output generated by the AI. Here, all of you. Any questions on it? Okay, so this is the transformer architecture. So all the modern LLMs follow this transformer architecture, guys, and they process the input. Sorry, they process the input and generate the output based on this transformer architecture. Okay, so remember this.
Could you please explain could you please explain positional encoding once again?
Yeah, so what happens is when the tokens, I had shown the tokenization process, right? So how it generated the tokens. So those tokens will give in the numbers. Okay, numbers. Like integers 1, 2, 3, 4, 5, let's say, and 6. So this is my embedding part. Then what happens is, because the mathematical models have been written, right, and the algorithms have been written, by analyzing the tokens, the encoder, as part of positional encoding, it will assign positional vectors. Vectors means, again, they are mathematical values like 0.3, 0.5. Okay, so they are basically the mathematical things. So based on that, the positional vector will be assigned so that the position is not lost. Means, the pattern, wherever the reference is present, right, as part of the parallel processing, the reference is present between all the tokens, so that is not lost. So that positional vector is assigned, and based on those positional vectors, then the self-attention mechanism will come into picture, and it will find out, which ones needs, what is the relationship between all of them, and what is the what kind of reference exists between all those tokens, what is the context, who all are falling into the context. Basically, all those things will happen as part of the self-attention mechanism. So positional encoding is nothing but we are assigning the positional mathematical vectors. You can read more about vectors, mathematical vectors, but also those things are being implemented in this case.
Sure.
Yeah. So this is about our transformer architecture, guys. Most of the LLMs, most of the AI models are using this transformer architecture for processing the input and generating the output. So, so the next one is, guys, okay, next one is prompts. So we'll learn about the prompts in the next session. So we'll stop the session here today, everyone. I think we are on time. Anyone has any other queries?
I have a question. How do you get the videos? Like, do you send it through email or you share the link?
So I didn't get your question. Can you please be a bit louder?
So the video for this session, would you send as an
Yeah,
email?
the video for the video
FL?
for the session, the video for the sessions are being shared in the WhatsApp group. So whichever WhatsApp group you are part of, please
okay.
check that group. On a daily basis, the recordings are being shared. Please go through the messages.
Okay.
The recordings are being shared.
Okay, thank you.
Or else you can put a question in the group, like to point to those recordings. I can respond to your message in the group.
Okay, thanks.
Okay. Yeah. Any other question, anyone? How are you all finding the sessions, everyone?
Very informative.
Thank you so much. Yeah, I
Very
hope you all
good.
are liking this. Yeah, I hope you all are liking the sessions, and please make the most out of it, guys. I encourage you all to please ask questions, get your queries resolved. If you are a bit hesitant to ask your queries in the session, you can ask your queries in the group also, or you can ping me one-to-one also, not an issue, or you can put your messages in the chat also. Okay. Okay, so with that, we'll stop the session for today. We'll resume in the next one. So thank you all for joining and have a good weekend.
Thank
Bye
you.
for now. Yeah,
Bye-bye.
please remember, guys, please note, we are not going to have the sessions on Saturday and Sunday. The sessions will happen from Monday to Friday, 8 p.m. to 9 p.m. IST. Thank you.
Okay. Thank you so much.
Thank you.